Hello, grade sevens. I hope you're all doing well today. In today's lesson, we're going to talk about what a fossil is, and then we're going to look at different types of fossils, and then we're going to conclude the lesson by talking about how a mold and a cast is formed. For this lesson, there's only one learning outcome, and that learning outcome is to describe the nature of different kinds of fossils and identify hypotheses about how they are formed. If I asked you right now to provide a definition of a fossil, or just describe what a fossil is, I suspect that you would describe a fossil by talking about how if you dug up a chunk of rock and you found the bones of a fossil the bones of a fossil that lived a very, very long time ago, that those bones would be a fossil. And that's correct. That is one type of fossil. We're going to provide a bit more of a general and expansive definition of what a fossil can be. So fossils are preserved impressions in rock used to identify when, where, and how organisms lived and behaved millions of years ago. There's three parts of this definition I just want to quickly focus on. So let's focus on how organisms lived. This might seem really hard to believe that if you just dig up the bones of an organism, it can tell us how exactly it behaved millions of years ago. The example I'm going to use is the one that's provided in the textbook. I suspect I'm going to mispronounce the name of the dinosaur that's described, which is an oviraptor. So when scientists dug up the bones of an oviraptor, they noticed that there were a lot of eggs in close proximity to these bones. Now, initially, what scientists thought is that the oviraptor was an egg stealer. It would go steal eggs from other organisms, and then it would hoard it close to itself, and then when it died, all these eggs would be in close proximity to it. More recent studies, which I don't know the details of, have suggested that the oviraptor actually was very protective of its young, so it would keep its eggs very, very close to itself, and then when it died, of course, the eggs are going to be in close proximity to the oviraptor. So a little indication about how the organism might have behaved a long time ago. The where, depending where you actually can dig up a fossil, it can give us a clue about what the Earth's climate was like a long time ago. I'm just trying to think. I believe in Antarctica, there have been quite a few fossils dug up, perhaps even some remains of some tropical plants. I'm not sure if that's Antarctica or in the Arctic, but nonetheless, what that tells you is if you have lots of fossils in Antarctica, for example, or the remains of tropical plants, it could tell you that a long time ago that Antarctica actually had a very, very different climate, a much warmer climate where these different types of organisms could actually live. The last part is, when did these live? We're not going to talk about this excuse me, in today's lesson. In the next lesson, we'll look at how we can take rocks and the fossils in the rocks and use different techniques to identify how old the rock actually is, but more on that'll come later. In the meantime, we'll look at 4 different types of fossils, starting with a petrified or a rock-like fossil. In this picture here, on that rock, towards the bottom of the rock, you should be able to see what it looks like, the bones of a fish. So when we talk about these bones that we find in a rock, as again, I suspected you would have provided with the initial definition of a fossil, that would fall into the category of being a petrified or a rock-like fossil. Now, let's just quickly talk about how these form. So what would happen is your organism would die, and then after it dies, all the fleshy parts of the organism would be eaten by scavengers, decomposers, until there's nothing left except for the bone. And then over a long period of time, eventually a lot of sediments are going to start to cover the the bones of like this fossil, and then this fossil will start to become covered by, as the sediments get compacted and compressed together, you'll find the bone inside of the rock. Now, if water passes through the rock and passes through the actual fossil, what it does is it dissolves a compound called calcium carbonate in the bones. So maybe we could just like draw this right here. So let's say that this fossil's in the rock, and then like a bunch of water goes through the fossil. And after it goes through the fossil, it takes this calcium carbonate away. So that fossil now has less calcium in it. What remains is deposits of silica or quartz. So in the picture I see here, that rock-like fossil of the bones of the fish is what's left over after the water has taken away the calcium carbonate from the bones. And again, silica or quartz is what remains left over. That's the rock that's left over, the petrified rock. 2, carbonaceous film. In this picture, it looks like you can kind of see like the outline of what I think is a wasp or a bee of some kind. What I don't see though is you don't have like the bones right here. What it looks like is you have like a bunch of little tiny particles of the bee. It's like the bee was there and something crushed it into a bunch of like really, really tiny little particles and made some kind of an imprint on the rock. In terms of a definition of what carbonaceous film is, when organic material just means it contains carbon in it, is compressed under many layers of sediment, the intense heat and pressure leaves an imprint or an outline on the rock surface. So yeah, really, really high heat and pressure has just crushed this organism into a bunch of little tiny particles, and then all we see left now is just this imprint on the surface of the rock. Third type of fossil, original remains. In this picture, it looks like there's an insect, and I think that insect is a mantis of some kind. And this mantis is inside, I believe, some amber. The reason that this one is called original remains is because you are preserving like what the organism originally looked like. Like nothing of it is really decayed. You haven't lost the fleshy parts. You still have the fleshy parts. They're being perfectly, well, maybe not perfectly, but they're being very nicely preserved inside of this amber. So fossils that we describe as original remains are you have that organism, and for the most part, it's been preserved. And there's different kinds of substances that can do this. Tar can do it, amber can do it, peat bogs, ice could do it as well. I think we found like woolly mammoths inside of ice. So in that case, we're again preserving most of the original part of the organism, hence the name original remains. 4, a trace fossil. In this picture, what I can see is I don't see any part of the actual organism that is remaining. So I don't see any remaining bone or rock. I don't see any crushed particles, and I don't see any of the original part of the organism being preserved. What I do see, though, is I can see a footprint. What this footprint tells us is it's evidence that there was something that passed through here at some point, and it did make some kind of a a marking into the actual rock. So even though we don't actually have any part of the organism, there's at least evidence that something was there, and that's called a trace fossil. Now, it doesn't just have to be like impressions in rock. Like there could be like holes in the ground. There could be footprints, as you see here, burrows, like animals like dig into the ground. Again, as long as there's like evidence that like something passed through there, then we refer to that as being a trace fossil. Last thing, I'm going to talk about mold and cast formation. This is a bit difficult to explain, so, and also very difficult to draw because I'm using a drawing tablet, but I'll do my best to just to sketch this here. Okay, I'm going to draw a picture, a very poor picture of a fish. So let's make here's my big fish. I'm going to draw some bones inside of the fish. Again, I apologize. I suspect this is not what an x-ray of the fish would look like, so I'll just pretend that this is what the bones of the fish are. Yes, I realize that is an arrow. Now, I'm going to shade in the skeleton part of the bone with a different color. So let's just do red here. So we'll say red equals the skeleton. Okay, shade this in as best as I can. Oops, that's not what I want it to happen. I'm not going to shade it all in. I'll just shade in as much as I can just to give you an impression that that's the actual skeleton of the fish. All right, so that red represents the skeleton, and this purple here I'll say that's the fleshy parts. So what's going to happen is when this fish dies, the first thing that's going to go is going to be that fleshy parts. Scavengers, decomposers would take care of that fleshy part. So let's get rid of it. I'm just going to erase the purple part here. Okay, so it's gone. So all I'm left with now is the actual bone. So a bunch of sediments are going to start to pack on top of this. So maybe I'll use a different color just to represent the ground or the sediments. Let's pick more like a brown maroon color for that. So we'll say, I'll call this brown. I'll call it the ground / the sediments. So a bunch of these sediments are eventually going to pile on top of the that skeleton, and that skeleton's then going to be beneath the ground. Now, over time, what's going to happen is, as we discussed in the petrified or rock-like fossil, water is going to pass through it, and as it passes through it, it's going to take away that calcium carbonate, and you're going to be left just with the silica or the quartz. Now, over a very, very long period of time, this rock right here can actually just disintegrate. So it's going to fall. It's going to just disintegrate into nothing here. It's going to fall apart. So I'm going to erase it. So the skeleton gradually dissolves. Let's get rid of the red. Okay, so it's gone. Now, what I have here is after that skeleton is all gone, what I have left is this outline here of what the skeleton looked like. So all of the particles in the ground, let's go back to this brown color. These particles in the ground would surround this here. Sediments in the ground, the rock surrounds this. And then that remaining skeleton, like I said, it just dissolves away. So let's get rid of it. Get rid of the blue. Gone. Now, what's left over here is this hollow portion after the skeleton is gone. And this hollow portion that's left over from the skeleton is what we call a mold. So a mold would just be all the particles in the ground that surround this region where the skeleton has dissolved away. So there's this hollow portion in the ground that we call a mold. Now, eventually what's going to happen is part of this mold right here is going to break, and then we're going to start to get this mold. It's going to get filled up with a bunch of sediments. So I'll draw like a bunch of little rocks right here just to show that. Now the mold is being filled with a bunch of sediments. Sorry, this is where I regret drawing the fish so big. When these different sediments fill the inside of the mold, that is what we call a cast. So let's just summarize the mold and cast formation. So a mold is an imprint left when an organism dies and is covered with sediment. Specifically, the organism dies, it's covered with sediment, and that skeleton dissolves away, leaving that hollow portion. And then, eventually, sediment starts to fill in the hollow portion of the mold. And once that sediment hardens, again, because it's underneath the ground, subjected to really, really high pressure. So this would start, these particles start to get like crushed or compacted together. Then we get a cast of the original organism. So that's the conclusion of the lesson. And what you need to complete is the assignment called fossils. I will talk to you next time.